So this is part 2 of our video series on algebra. And so I want to discuss direct and inverse variations. And we'll look at inequalities and we'll look at some graphing. So to get started here, we're going to look at when we're solving equations, we can have direct variations and inverse variations. And a lot of that means, for instance, if you're running 6 miles per 1 hour, how far can you run for 3 hours or 4 hours? And so as the number of hours increases, we would see that the distance traveled will also increase. So this is a formula for your direct variation. So you've got y is equal to kx, and k is what we call a constant. Of proportionality. It's a constant of proportionality. And then we also have a y equals k divided by x, which is what we would say is our indirect variation. And what we'll notice with an indirect variation is that as the x increases, the y will decrease. So a little different than what we saw up here, where as x increases, y increases. Well, a direct variation would be as x increases, y would decrease. So let's look at an example, and we'll look at it from as it varies directly to as varies indirectly. So the value of y we see varies directly with x. So y is equal to kx, and if x is 12, I just want to figure out what k would equal when y is 30 and x is 12. So I'm just going to divide both sides by 12. So that would give me k is equal to 30 twelfths, both 30 and 12, both divisible by 6. So that would give me 5 halves, or 2.5 to equal k. Well, now that I know that, then I want to come back over here and say, well, I know that it varies directly, so find the value of y when x is 18. So that's 2, and I can use 2.5, or I can use 5 halves, either one. So 18 times 2 is, what's that, 36, and then if I also need to take half of 18, which is 9, which would give me 45. Or I could look at, well, 5 times 18 is 50, 5 times 10 is 50, 5 times 8 is 40, so that's 90 halves, which is also 45. So when x is 18, y is 45. And that would go along with the patterns that we saw. As x increases, y increases. Well, if we look at the same thing, and let's say that y varies indirectly with x, and we'll just use the same idea there. When x is 12 and y is 30, so y is equal to k divided by x. And so trying to figure out what k would be in this situation. So if x is 12 and y is 30, so I would multiply both sides by 12, and that would be what, 360 is equal to k. So if it varies directly, now let's say that if x is 18 and it varies indirectly, figure out what y would be, well, that would be 360 divided by 18, and that would give us our value of y. And so that would give us 20 as an answer. All right, so now we're just looking more at expressions and the words that would be part of expression. So when you're thinking of more than or greater than or increased by or even sum, when we see the word sum, all of that dealing with addition, or decreased by or less than or difference, all of that representing subtraction, or multiply or product or times, those are all representing your multiplication, or double or triple, split, quotient, any of those would represent your division. So you got, many times you got keywords that that you will see as part of the wording that will help you formulate your equations. So here we've got Matthew and John ran a total of 48 miles in 1 week. Matthew ran 14 miles more than John. How many miles did they run? Did each of them run? So my variables, I'm going to say X is John, and we'll say Y is Matthew. We'll say X plus 14 is Matthew because Matthew ran 14 more than John. And so we're going to have X plus 14, and all that's going to equal 48. So when we add our like terms together, we're going to get 2X plus 14 is equal to 48, and then we're going to subtract 14. So I'm using my inverse operations. I'm going to get 2X is equal to 34. So this is going to divide by 2, so X is 17. So this means this is what John ran, since we said John was representing X. So 17 plus 14 is going to be 31. That's what Matthew ran. So if we say 31 and 17 and add them together, we're going to get 48, which is what we know they ran together in 1 week. Here we've got a local business donated $192,000 to 3 charities: Girl Scouts, Boy Scouts, and the Girls Club. So the ratio of the contributions to Girl Scouts, Boy Scouts, and Girls Club was 5 to 2 to 1, respectively. So we're going to say that X will be the Girls Club, and we'll say 2X is equal to Boy Scouts, and we'll say 5X is equal to Girl Scouts. So we know there was $192,000 contributed and donated to these. So we would have 5X plus 2X plus X. And so this is, I'm just going to write the 1 because we can see that that is that 5 to 2 to 1 with those respective places there, so in clubs. So now let's go ahead and combine our like terms. So this will be 5X, 2X, and 1X. So that's going to be 8X is equal to 192,000. And then we just want to divide both sides by 8. So X is equal to 24,000. Now what does that represent? Well, that's going to represent what was given to the girls' club because that's what we said was X. And so the girls' club was 24,000. And then the boys' club would be 24,000 times 2, so we would get 48,000. And then the girls' club would be 5 times the 24,000. And that would be 120,000 because we want to go 5 times this 24,000. So 120,000, 48,000, and 24,000 would be the amounts given to each. All right, switching gears, we're going to look at graphing linear equations and inequalities. So any equation with a variable or variables raised to the first power is called a linear equation. Now, when solving inequalities, we want to use the inverses just like we were solving equations. However, there's one thing that we have to remember, and that's when we are multiplying and dividing with inequalities. When we divide by a negative, when multiplying or dividing by a negative sign, you will need to reverse that inequality sign. So that's something you got to keep in mind as you're solving. So here, I see a factor of 3 and a factor of 6x minus 1. So I'm going to use the distributive property to simplify this. So this will be 3 times 6x minus 3 times 1. And so this will be 18x minus 3 is greater than 18 minus 3x. So I want to get my variables on one side and my constants on the other so I can graph this. So I'm going to add 3 over here. And that's going to go to 0. So that's going to leave me with 18x is greater than 21 minus 3x. And now I want to add 3x to both sides. So that goes to 0. So 18x and 3x is 21x. 21x is greater than 21. So if I divide by 21, notice I divided by positive 21, so I don't have to reverse the symbol. It's going to be x is greater than 1. So I want to come over here to 1, and I want to put an open value here because I want everything greater than 1, but not equal to. And that comes from looking at your inequality sign in the beginning. And notice that was greater than and not greater than or equal to. So with this one, I want to go ahead, I see the parentheses, so I want to go ahead and distribute. So that's going to be negative 2x minus 4 plus 4x. And on the left side, I have 20 take away 2x. So I want to try to get my variables on one side. So I'm going to add the 2x here. And so I'm going to get 20 is greater than or equal to, this goes to 0, and I get negative 4 plus 4x. So I decided to put my variables on the right and my constants on the left, so I'm going to add 4. So this will be 24 is greater than or equal to 4x. And this is a positive coefficient, so when I divide by 4, 24 divided by 4 is 6. So 6 is greater than or equal to x. 6 is greater than or equal to all of the solutions. Or I could say x is less than or equal to 6. These mean the same thing. Just notice that the variable, if it's on the right, what the inequality would be, and what if the variable's on the left. Okay? So this means that since it's a greater than or equal to symbol, and the answer is at 6, so I'm going to enclose it. I'm going to include, this is one of those inclusive situations with your solutions. You're going to include 6 because of the less than or equal to. So I want everything less than or equal to 6. So that's my shading on a number line to show all the possible solutions. All right, so let's look at solving absolute value equations and inequalities. So absolute value equations and inequalities can be graphed on a number line. And the expression inside the absolute value signs can be positive, or they could be negative. So we should solve it both ways. We want to look at the positive side and we want to look at the negative side. So with this absolute value equation, I want to look at what's inside the parentheses, and I want to say negative 2x plus 6 is equal to 6. And I also want to look at the negative side of that, what was in parentheses. So that's going to be negative, and then negative 2x plus 6, and then close that, and equal to 6. All right, so I want to work this 2 different ways. So here I'm going to start and subtract 6. So this is going to be negative 2x is equal to 0. So that means x has to equal 0. And so when I substitute back into x to check, I would say, well, negative 2 times 0 is 0, and 0 plus 6 is 6. What's the absolute value of 6? 6, so therefore it equals 6. Over here, what I want to do is I'm going to divide by this negative 1 that's out here. So I'm just going to divide both sides by negative 1, and notice it changes it to negative 6 on the right side. So I've got negative 2x plus 6 is equal to negative 6. So I want to subtract 6, and that'll be negative 2x is equal to negative 12. X is equal to positive 6. So now let's check. What's negative 2 times a positive 6? That's a negative 12. What's a negative 12 plus 6? That's negative 6. So then what's the absolute value of negative 6? That's a positive 6, so therefore 6 equals 6. So here are your 2 answers to this absolute value equation. All right, so let's look at part B. And you got to be careful with some things. You cannot start off with 2 minus 5. You cannot start off here and say that that's negative 3. So what we're going to do is subtract 2. And so this will be negative 5 multiplied by the absolute value of 5x minus 5 is equal to negative 75. Now I want to eliminate this negative 5 as a factor. So I want to divide both sides by negative 5. And now that's going to give me 5x minus 5, absolute value, is equal to positive 15. So now we're going to take this and we're going to solve it like we did over here. We're going to solve it 2 ways. So what's 5x minus 5? That's going to equal 15. And then we're going to take the negative of that. So I'm going to add 5. So 5x is equal to 20. So x is equal to 4. And then over here, again, I'm going to divide by negative 1. And I'm going to get 5x minus 5 is equal to negative 15. Add 5. I'm going to get 5x is equal to negative 10. Divide by 5. I'm going to, on both sides, I'm going to get x is equal to negative 2. All right, let's look at another one. And so here's where we're dealing with an inequality, not an equation. So we can have, we'll be able to shade our answers on the number line. So I want to add 6 to both sides. So now I'm going to get absolute value of x plus 5 is less than negative 5 plus 6, which is 1. And I want to do the same thing that I was doing with the equations. I want to take x plus 5 is less than 1, and negative times x plus 5 is less than 1. So on the left side, I'm going to subtract 5, and so that'll give me x is less than 1 take away 5, which is negative 4. And then over here, I'm going to divide by a negative. So remember what happens when we divide by a negative? That reverses the sign here to here. And that will be 1 divided by negative 1, which would be negative 1. If I keep going, I'm going to get x is greater than negative 6. So I want to graph these two. So I'm going to say x is less than negative 4. And I'm going to open interval there because this is just a less than. And I want everything less than negative 4. But then I want to come over here and graph negative 6, and I want to leave it open, and I want to graph everything to the right of it. So what we will see is an intersection of right in here. So those are the solutions there that will make this inequality a true statement. All right, let's look at another one. So I want to subtract 6 to start out. So this will be 9 multiplied by 3x minus 2. That goes to 0, and this will be greater than 45. And then I want to divide by 9. So this will give me the absolute value of 3x minus 2 is greater than 5. So see how I just wanted to clear off all of what was out here. It was the 9, it was the positive 6, so I just wanted to clear all that out to where I just have the absolute value, and now I want to work the two inequalities. So this will be 3x minus 2 is greater than 5, and negative 3x minus 2 is greater than 5. I'm going to add 2. So I'm going to get 3x is greater than 7. 3 will not divide 7 evenly, so I get x is greater than 7/3. And so that's, so what, 7/3 is what, 2 and 2 1/3. And so that's positive, and everything is, notice it's just a greater than. So at 2 1/3, somewhere right in there, I'll leave that open, and then I want everything greater than 2 1/3. And then I want to come over here and solve this one, and I'm going to divide by negative 1. So when I do that, that's going to give me 3x minus 2, but I divided by negative 1, so this has to change to less than negative 5. I'm going to add 2. So 3x is less than negative 3, so x is less than negative 1. So I want to come over here to negative 1 and an open interval, and then I want everything to the left. So this is one of those union of two sets. So I've got everything that every order or every value to the left or every value to the right will make this a true statement. All right, so let's look at equations with two variables. And the coordinate plane consists of an x-axis and a y-axis. Each axis consists of negative and positive values. And the point at which the two axes, plural, intersect is called the origin. And that ordered pair is 0, 0. So when you're looking at an ordered pair on a number line, it would look like some of these where A and B and C and D. Those are plotted, and we want to plot. Just remember that when you're plotting ordered pairs, you want to plot your X first, and then, so your X is going to either be going to the right or going to the left, and then you're going to plot your Y second, and that's going to either go up or that's going to go down. And so you've also got quadrants. So quadrants hold certain values in a coordinate plane. Quadrant 1, notice that everything in this region, X and Y, are both positive. Everything in quadrant 2, notice that every X is negative, but the Y is positive. In quadrant 3, notice that X and Y are both negative. And then quadrant 4, X is positive, but Y is negative. So when you look at point A over here, that's going to be 2, negative 2, and that falls into your fourth quadrant, which is the X is positive and the Y is negative. Point C is going to be at 2 and 4, so we move to the right 2 and then up 4, and that will fall in quadrant 1, where X is positive and Y is positive. And then D is going to be negative 2, 2, and that's going to fall in quadrant 2, where X is negative and Y is positive. And then point B is going to be negative 2, negative 2, and that's going to fall in quadrant 3, where X is negative and Y is negative. Okay, so then we can look at, well, each point on the coordinate plane consists of an X value and Y, and each value is called, it's called a coordinate. And that coordinate pair, remember, is in a form X comma Y, just like the alphabet. X is going to come first, and then Y will come second. Well, then, when we're talking about linear equations, we can also look at slopes of lines between 2 points on a coordinate plane, and that's called your rate of change, or it's called your rise over run, or that slope formula where we're looking at the change in Y divided by the change in X. You might even see it as change in Y, delta X. So the delta just means change. So let's look at, find the rate of change. So I just want to use this formula. So it doesn't matter if I start with Y2 or Y1, I just need to be consistent. So I like to move left to right. So I'm going to start with negative 5, and I'm going to subtract 7. And then I'm going to come back and grab my X value and say 7 take away 4. So negative 5 take away 7 is going to be negative 12. 7 take away 4 is 3. And then I just want to simplify that. Negative 12 divided by 3 would be negative 4. So the slope of the line that falls with, that connects those 2 points is negative 4. So it's a whole number. I can write it as negative 4 to 1, but we usually see it as just an integer. Here I like to go left to right, so I'm going to start with -8, the y value, and then I'm going to subtract 2. So I took my y and subtracted y, and then I'm going to come back to this x and subtract the other x. So what's -8 take away 2? That's going to be -10. And then what's 3? Subtract a negative. That's going to be 3 plus 5. So -10 divided by 8 would be -5/4. I would encourage you to always simplify your slope. And many times if you're working with multiple choice answers, you're going to see it as a simplified form. Here I'd like to write an equation of a line where you're given the slope and it's got to go through a point. So we're going to use our slope-intercept form, y equals mx plus b, where m is going to represent slope and b is going to represent what we'll call our y-intercept. Hence the name slope-intercept form. So what do we know? All right, well, we know that slope is 4 from our information here. And so 4 multiplied by the x that's given in the 5, -12. I don't know what my intercept is, but I know that y is -12. So it's just a substitution, and then we want to solve. For the variable b, which is our intercept. So 4 times 5, that's going to be 20. So now I'm going to subtract 20. So this will be -32 equals b. So I've got my intercept, I know my slope, so my equation would be y equals 4x minus 32. This equation has a slope of 4, an intercept of -32, and it's going to go through this point of 5, -12. All right, let's write an equation that you're given 2 points. So that's all you're given are 2 points, and you want to write an equation in slope-intercept form. Well, first we got to figure out the slope. So I'm going to move left to right, and I'm going to take -4, which is a y value, and subtract the other y value, which is 0. And I'm going to come back and take the x and subtract the other x. So this is going to be -4 in the numerator and 7 plus 5 in the denominator. So that's going to be -4 plus 12, or -1/3. So slope is -1/3. And now you just have to pick one of these points. And it doesn't matter which one you pick. And since we think about efficiency, I would like to use the one with the 0. So I'm going to substitute back into this form because I want to create an equation like that. And so I'm going to use the point -5, 0 with a slope of -1/3. So it's just a substitute. So -1/3 for m, -5 for x, and 0 for y. So 0 is equal to 5/3. That's what -1/3 times -5 would equal. And so if 5/3 plus b is equal to 0, then I want to subtract 5/3. So -5/3 is equal to the intercept. And so my equation now is going to be y equal -1/3 x minus 5/3. Remember where I got the -1/3 from? That was up here that I found from over here. And then the -5/3 was found by substituting into y equals mx plus b. And so that slope-intercept form is y equals mx plus b. So if I'm given a slope of -3 and it's got to go through a point -3.7, so I know the slope is -3, and I'm going to use this point. So -7 goes in the place of y, -3 in the place of m, -3 in the place of x, and let's solve for the variable. So this will be 9 plus b is equal to -7. So if I subtract 9, I'm going to get -16 equals b. And I know the slope, so I'm going to piece these two together and write y equal -3x minus 16. This equation will model this, where it's a slope of -3 and it goes through the point -3, -7. And so that will conclude part 2 of this video series about algebra.